So OPFLEX is an API, and we've defined this, it's what runs between an SDN controller, or our controller, but could be from with other controllers, and the underlying switches. And so it provides an abstraction that we think is much more appropriate for scaling out control overall. And it is an open source effort, so we've published a draft in the IETF, but we will also be doing an OBS implementation that will be made available into the public domain, as well as a controller in the Open Daylight Consortium that will control that OBS switch. And the idea here is that if we have open APIs, then we can bring in more and more equipment under that management umbrella, that SDN management umbrella, which in our case is an application-centric controller, but ODL would be an example of a non-application-centric controller that uses OPFLEX. It's a very, it's a general model that allows you to communicate a policy model, which is very different than something like OpenFlow, which is a way to direct a switch at a very fine grain. It's, the difference we'd like to talk about is the difference between an imperative model and a declarative model. And give you an example of the difference. An imperative model, if the air traffic control system ran with an imperative model, they would say, okay, you're in a Cessna 152, push on the left pedal, halfway down as you come around to get into this runway. A declarative model says, go to heading 172 and come down at this speed. And so it's a much higher level and allows the underlying device to be responsible for carrying out that overall declarative thing. And so higher level. That allows for much more scale. So now in our case, we create a logical model of a switch. We can change the switch in and out, but the controller is exactly the same. And it talks to this model of a switch. And the switch is responsible for rendering between the logical model and what we call a concrete model, the actual implementation under the covers. And that allows, the controller doesn't have to be involved in the specifics of a particular switch. It allows it to run at a higher level, say, well, you're going to enable this feature, and let it be the responsibility of the switch to take care of that. This is an example of what I talked about in the talk now about a balanced approach where we don't want to pull everything out of the switch, but we want to pull some stuff out of the switch. And so there are some things that make sense to be centralized and some things that make sense to be distributed. And particularly that deals with response time, dealing with local events very, very quickly, low latency, and overall scale of the system. It's an open technology. The IETF draft was signed on by Microsoft and Red Hat and Citrix and F5 and some others. I mean, you can pull the draft on the IETF. And then the ODL consortium is a whole lot of companies. Virtually every networking company that I can think of is involved in the ODL community. And then OVS, of course, is open source through the Linux distribution. So absolutely open.